Today, we will use a scientific perspective to explore the complex truth behind meteorological events. According to the latest news from the New York Times, on November 28th, parts of northern and western New York were covered with heavy snow, and lake-effect blizzards continued to hit the area. The snowfall rate of this storm exceeded 1 inch per hour, and meteorologists warn that about 35 miles per hour winds may produce blowing and drifting snow. Snowfall on Lake Erie intensified throughout the morning, with the heaviest snowfall concentrated south of Buffalo, which was paralyzed by lake-effect snow on Christmas Eve last year. By 11 a.m., the storm had dropped more than a foot of snow on towns and villages south of Buffalo. In Hamburg, the police department warned residents to drive with caution after reports of multiple crashes and delays to emergency services. In Orchard Park, officials said many roads remain snow-covered, slippery and filled with abandoned vehicles blocking driveways. Thank you for liking, leaving comments, subscribing and turning on the little bell. We will update every day. In communities east of Lake Ontario, New York, most areas saw snowfall amounts between 12 and 18 inches, but some areas saw much higher snowfall totals, such as the village of Constable Greenville, which has a population of about 300 people. Nearly 10 residents were besieged by the blizzard. 2 feet of snow. Taylor, a meteorologist with the National Weather Service, said on Tuesday that the worst of the lake-effect storms are largely over. But by November 29th, additional bands of snow could fall about 6 to 12 inches more. As of early Tuesday, more than 3 million people were under lake-effect snowfall warnings from far eastern Ohio to parts of upstate and western New York. Up to a foot of snow fell in parts of northeast Ohio and northwest Pennsylvania, the Weather Service said. The Ohio Department of Transportation said on social media that hundreds of crews were clearing heavily snow-covered roads across the state. The Cleveland Metropolitan School District, which has about 35,000 students, said schools were closed Tuesday because of the weather. Video posted to social media appeared to show extremely poor visibility and traffic coming to a standstill in the Buffalo area. The New York State Thruway Authority reported crashes, vehicle breakdowns and delays on Interstate 90, which crosses the state from east to west. Service may be slowed due to heavy snowfall and slippery roads. Lake Ontario is located between the United States and Canada and is the largest freshwater lake in North America. The topography of the area around it makes it highly susceptible to the so-called lake effect. When cold air blows from the north and northwest, it encounters the heat and water vapor released by the lake water, creating a strong convective system and lakeshore snowfall belts. This is known as a lake effect snowstorm. First of all, Lake Ontario itself is a huge heat reservoir and water vapor source. The temperature of the lake water is higher than the air temperature most of the time, especially in late autumn and early winter. So as soon as the air hits the lake, it gains heat and water vapor. This creates conditions for convection and precipitation. Secondly, the southeastern shoreline of Lake Ontario forms a clockwise arc-shaped bay, which allows cold air from the north and northwest to stay in this area for a long time and continuously obtain heat and water vapor, released by the lake water. This makes it easy to form a low-pressure system centered near the lake shoreline. This low pressure will cause cyclonic wind fields, forming the traditional lake effect snow belt. More importantly, the jet stream north and northwest of Lake Ontario will also affect the weather system here. When the North American continent is covered by polar cold air, the surface high-pressure ridge generated by the sinking air produces strong westerly airflow. Once this airflow encounters Lake Ontario, it will produce a violent upward movement. Forced upward motion will cause the air to rapidly cool and condense, producing a large amount of precipitation. At the same time, due to the influence of climate change, the intensity and movement trajectory of the polar vortex have also changed in recent years. This makes it easier for Arctic cold air to move southward, creating more blizzard conditions in the Lake Ontario region. Model predictions show that extreme winter weather events will continue to increase in the context of climate warming. In addition to the areas surrounding the Great Lakes of the United States and Canada, there are also areas prone to lake effect snowstorms. For example, cities around lakes such as Lake Shikotsu, Lake Toya, and Lake Harubsu in the northeastern part of Hokkaido Island, Japan. They are also in the area affected by the Arctic cold air brought by the westerly wind, and under the favorable conditions of water vapor provided by the lake water, they are prone to heavy snowfall. Secondly, cities around large lakes such as Lake Balkhash, Lake Baikal, and Ober in Central Asia and Siberia, such as Dinamud, Irkutsk, and Ulaanbaatar, are also prone to lake effect snowstorms. In addition, some cities around lakes in regions such as Northern Europe and the Alps are prone to more severe lake effect snowstorm disasters, due to similar terrain and climate reasons. Such cities include Geneva, Zurich, Bern, Munich, etc. Regarding lake effect blizzards, they have different characteristics from ordinary blizzards. First of all, the main mechanism for lake effect blizzards to produce extremely heavy snow is that lake water provides sufficient water vapor for cold air. Unlike ordinary snowfall weather, lake effect snowstorms rely on the supply of lake water, a huge water vapor factory. Large lakes store large amounts of warm, moist air. This moist air is entrained and forced to rise by the cold air. During the rising process, the water vapor quickly condenses into snow. Secondly, the vertical movement intensity of the lake effect snowstorm is extremely strong, and the convective cloud towers are extremely developed. The water vapor on the lake surface is strongly humidified and unstable, which will produce violent convection and updrafts driven by cold air. In this way, it is easy to form large-scale convective cloud systems with a height of tens of thousands of meters, and the cloud tops can even touch the stratosphere. In addition, lake effect blizzards can produce unusually heavy snowfall up to several inches per hour. Due to the extreme water vapor transport caused by forced convection, the snowfall level of lake effect storms is far higher than that of other mid-latitude cities. The amount of snow in 24 hours can reach 100 centimeters, breaking historical extremes. What's more, lake effect blizzards have unusually strong winds. The interaction between cold air and the lake surface creates a significant pressure gradient, which can produce unusually strong wind fields near the ground and at high altitudes. A normal snowstorm with Category 8 to 10 winds will be upgraded to a Category 11 to 12 hurricane. At the same time, the spatial scope of lake effect snowstorms is extremely localized. Affected by the topography, lake effect snowstorms are mostly localized within a few dozen kilometers nearby. The outbreak was concentrated, and the weather in the surrounding areas was normal. This is different from ordinary mid-latitude cyclonic storms. What cannot be ignored is the abnormal distribution of lake effect blizzard snow bands. There are obvious arc-shaped or spiral snow belts on both sides of the lakeshore area. This is closely related to the changes in lake shoreline, topography, and wind field, and is also one of the signs that best reflects the lake effect. Such extreme snowstorm events often bring all kinds of extreme damage and impacts. First of all, the most direct consequence of extreme snowstorms is the paralysis of transportation. Heavy snow quickly covers roads, causing severe skidding of motor vehicles and even serial collisions. Railway transportation can also be completely interrupted when heavy snow collapses telephone poles and blocks lines. Planes also had difficulty taking off and landing normally. These make travel difficult and cause serious chaos in urban operations. Secondly, power supply interruption accidents occur frequently. Blizzards are most likely to damage power lines and power transmission and distribution equipment, causing power outages or partial power outages. Power grids in developing countries are more vulnerable, and blackouts can exceed millions of people. This involves all aspects of residents' normal lives, commercial activities, and the operation of important facilities. At the same time, the most disastrous characteristic of blizzards is their suddenness. Unlike hurricanes and floods, blizzards are fierce and often reach their peak within a day or two. This poses serious challenges to emergency response. In recent decades, sudden extreme snowstorms have occurred around the world with unprecedented destructive power. What cannot be ignored is that snow collapse accidents are also important secondary disasters. Heavy snow quickly accumulates on the top of the building, and it is easy to collapse when the design load is exceeded. This has a particularly severe impact on temporary structures and residential housing in developing areas. In addition, large-scale urban functional failures are also prone to occur. A series of traffic disruptions, power outages, ruptured pipelines, and other problems caused by blizzards can cause the entire city to fall into epilepsy. This is also a severe test for the operation of important infrastructure such as hospitals and emergency centers. To sum up, the destructiveness of extreme snowstorms mainly comes from its suddenness, large-scale impact, and vulnerability of urban systems. Relevant departments should start from the aspects of risk assessment, early warning speed, facility resilience, emergency response, etc., and strive to reduce the harm of such incidents. The most serious extreme snowstorm event in history can be traced back to the blizzard event that occurred in the northeastern United States in the 1980s, which caused huge losses of life and economics. It was one of the most serious extreme snowstorm events on record. This so-called big storm occurred in March 1993, covering the entire eastern United States, from Virginia all the way north to Maine. The amount of snow and wind speeds brought by this blizzard are unprecedented. A large number of areas saw 2 to 3 inches of snowfall per hour. The wind speed reached 130 kilometers per hour, and the Boston area even experienced nearly hurricane-level winds. This blizzard of the century caused huge losses. The heavy snowfall alone caused more than 300 deaths and caused economic losses of up to $3 billion. Traffic was devastated and thousands of civilian vehicles were stranded on the roads. Airports, schools, and railways were all paralyzed. Tens of millions of residents lost power and heat in their homes. Escape and self-rescue methods are especially important when individuals encounter extreme snowfall outdoors. First, find shelter as soon as possible. This is your key to surviving successfully. You can identify any building or facility that can temporarily shelter from wind and snow, such as village houses, abandoned warehouses, caves, dense forest areas, etc. Remember not to stay in open areas. Secondly, contact rescue and wait for rescue. Call emergency services immediately to report your location and describe the situation in detail. Stay in a shelter and maintain your strength until professional search and rescue personnel arrive. Locations can be marked using fire, shooting, etc. At the same time, pay attention to keep warm and be on standby. Body temperature is lost rapidly in extreme snowstorm conditions, and all measures must be taken to prevent hypothermia. Examples include isolation from wind, burning fires for warmth, and body fit to reduce heat loss. If necessary, you can do a small amount of activity to speed up metabolism and generate heat. When it cannot be ignored, prepare enough food and fresh water. Snowstorms may block roads for several days or even longer, and individuals must prepare at least 3 to 5 days of rations and water to maintain physical strength. You also need to carry necessary first aid medicines and other supplies in case of accidents. Also, be aware of avalanche and collapse hazards. During your evacuation in mountainous areas, be sure to stay away from cliffs and steep slopes where avalanches may occur. When entering a building to avoid snow, pay attention to the risk of structural damage and avoid areas that may collapse. When it cannot be ignored, weather trends must be closely followed. Use radio and other methods to listen to the latest weather reports and keep abreast of the development of extreme weather, so that you can take timely action. This is extremely critical to a successful rescue. As a community, how to organize rescue and explain to residents when encountering extreme snowfall events is also very important. First, shelters must be open to accommodate disaster-stricken people. Use gymnasiums, schools, community centers, and other places as temporary shelters to provide heating, food, drinking water, medicine, and other daily necessities to the victims. Register disaster victims and report to superior departments the supply of supplies that need support. Secondly, a volunteer team should be formed to carry out rescue operations. Mobilize volunteers from inside and outside the community to join the rescue team to assist in emergency tasks such as search and rescue of trapped persons, medical transportation, and road clearing and dredging. Establish an inspection system to inspect key dangerous areas such as areas with heavy snow on roofs and areas with excessive snow accumulation. More importantly, efforts must be made to repair power supply, water supply, and other important infrastructure. Interruptions in water and electricity supply can have a serious impact on community life. Organize technical personnel to make every effort to repair relevant power grid power supply equipment and carry out temporary power supply construction. At the same time, we will make every effort to connect the water supply pipe network and restore water supply as soon as possible. To reduce the losses caused by extreme snowstorms, the key is to further predict and avoid the occurrence of extreme snowstorms. There is currently a lot of international experience in this regard. First, an early warning indicator system must be established to improve prediction accuracy. Construct new early warning indicators that combine historical statistics, numerical simulations, machine learning, etc., and model important parameters such as precipitation, wind speed, and visibility to make blizzard forecasts more than 12 hours in advance. Increase the frequency of forecasts and shorten the release time. Secondly, it is necessary to enhance the weather radar monitoring capabilities and improve the capture rate of local heavy snowfall. Use multi-beam, multi-elevation angle radar to expand the detection range and increase spatial and temporal resolution. Make full use of dual polarization and multi-band technology to improve early identification of extreme weather. Actively apply new technologies such as mobile surveying and mapping radar. At the same time, a refined numerical prediction system for the snowstorm process should be established. Combining terrain, soil type, and surface characteristics data, and using technologies such as large eddy analogy, cloud microphysics, and data assimilation to cultivate high-precision regional and urban snowstorm forecasting capabilities. Achieve accurate quantitative prediction of local heavy snowfall. When it cannot be ignored, we must continue to observe and study the evolution of the weather system. Carry out continuous tracking and comprehensive analysis and judgment for upstream weather systems that may cause heavy snowfall downstream. Monitor the development direction, intensity, and movement speed changes of the system to lay the foundation for early warning. In addition, it is also important to strengthen the in-depth integration of meteorological elements and socioeconomic data. Fully combine traffic conditions, road weather, important activities, and other information to establish a unified information service platform. Realize the deep coupling of meteorological elements with transportation systems and power systems to improve the timeliness of snowstorm warnings. At present, some countries have more experience in preventing and avoiding extreme snowstorms and are worth learning from. First of all, Japan has rich experience in snow disaster prevention, disaster reduction, and relief. Many places in Japan are in areas prone to heavy snowstorms, and there have been many major snow disasters in history. The Japanese government has therefore formed a relatively complete snow disaster management system, setting up large and small strategies and adopting various comprehensive snow disaster prevention and reduction countermeasures that combine engineering and non-engineering. This provides a model for other countries. Secondly, the northeastern states of the United States, such as New York State and Massachusetts, have also accumulated rich experience in snowstorm disaster management. These states are located in downwind areas, are responsible for important industries and high-density population areas, and frequently encounter extreme weather such as lake effect blizzards from the Great Lakes. Relevant state governments and cities have successively introduced comprehensive policies to deal with such extreme weather, and adopted various engineering and non-engineering means to effectively reduce the losses caused by snow disasters. In addition, meteorological departments at all levels under Environment Canada have long been engaged in blizzard warning services, and have accumulated rich experience in weather forecasting and risk assessment. The storm indicator rating system they developed provides an important basis for extreme weather warnings. At the same time, Canada's Ministry of Natural Resources has also developed comprehensive risk assessment and risk management standards and regulations. At the same time, Nordic countries such as Norway, Finland, Sweden, and other countries, as well as Alpine countries such as Switzerland and Austria, have also accumulated rich experience in blizzard disaster management due to frequent local blizzards, and have been involved in snow damage prevention and control projects, and public disaster prevention awareness cultivation. It is worth learning from other aspects. This kind of extreme snowstorm weather poses serious threats to transportation, power supply, urban operations, and mass travel in these cities. Relevant departments need to strengthen meteorological warning and disaster prevention and reduction work to reduce the harm of such extreme weather. Thank you for liking, leaving a message, subscribing, and turning on the little bell. We will update the latest news from around the world every day. Continue to use a scientific perspective to explore the complex truth behind meteorological events.